All right, so let's start with the I can statement for the medians in triangles. So I can find the point of concurrency for the medians of a triangle, and our vocabulary is altitude, median, concurrency of medians theorem, centroid, center of gravity. All right, so again, we're going to start with the writing. So a median of a triangle is a segment that has endpoints at a vertex and the midpoint of the side opposite the vertex. An altitude is a perpendicular segment from a vertex of a triangle to the line containing the side opposite the vertex. All right, anybody still writing this down? All right, try example 1 on your own. See if you can identify these: median, altitude, angle bisector, and perpendicular bisector. All right, so check those out. See what you can identify. All right, let's check it out. Big reveal. Here you go. Make sure you have these. All right, any questions on these? All right, so I'm giving you these sketches below. So it says sketch the medians of each side of each triangle below. All right, so it says, what conjecture can you make about the concurrency of medians of a triangle? First off, one thing I forgot to put here is that the points are always inside the triangle, but the long side looks to be 2/3 of the smaller side. So I'll give you a minute to write that down. All right, show of hands who's still drawing and writing this out. Okay. All right, anybody else still writing this? Dan, are you caught up? Okay, so let's take a look at the current concurrency of medians theorem. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. If P is the midpoint of, if P is the point of concurrency of triangle ABC, then AP is equal to 2/3 AZ, BP is equal to 2/3 BX, and CP is equal to 2/3 CY. All right, so again, just to kind of give you an idea here, if we just looked at AZ, this is 2/3 the length of the entire thing, and PZ is 1/3 the length. Show hands who's still writing. Okay, so the point of concurrency of the medians of the triangle is called the centroid. The centroid divides the median into two parts, one part being half the length of the other. So if you guys recall, remember that larger part is 2/3, the smaller part is 1/3 of the line. That means that smaller part is half of the longer part. okay? The larger part extends from the vertex to the centroid, and the centroid is also called the center of gravity, okay? And that means that the centroid is the point at which a triangle can be balanced. Now, unfortunately, we don't have time for that today, but if you construct a centroid on a triangle and then take the tip of your pencil, it will, if done correctly, I should state, it will perfectly balance on that triangle. And the triangle will just kind of sit there. It's actually kind of cool. I'm sorry we can't do it. But you do have to cut out the triangle. That's why you can't just have the piece of paper there. Okay. Is anybody still writing this down? Okay. Let's take a look at our next example then. So example 2. Now remember, stick with me here because it's not hard, but it's little things, right? So if AP is 22, find PZ and AZ. All right, so PZ is easy because PZ we just said is half of the larger segment because that's a smaller one, right? So it's half of 22, which gives you 11. And then when you're finding AZ, you're just going to add the 22 plus the 11, giving you 33. Does that make sense? Yeah, it is easy. It's just like wrapping your head around the fact that you have something that is, half of 2/3. Sometimes that's the hardest part. Because I know we all love fractions in here, right? No? Fraction friends? No? It's just friendly fraction friends. All right, I want you guys to try 3 and 4 on your own. I will randomly call somebody to give me the answer. All right, is anybody still working on these 2? All right, let's see who's first. Nick, what were your answers for number 3? There we go. Questions on that? All right. Next one. Macy. Very good. All right, questions on that? All right, let's talk about calculating the centroid given the 3 points. Now, these are easy. You do not necessarily need to graph this, but I do want you guys to look all the way at the bottom here. A triangle with 3 vertices has a centroid of the sum of the x's divided by 3 and the sum of the y's divided by 3. So that makes us a lot easier, but you're going to want to circle this, highlight it, something like that in order to be able to calculate this easier. Okay. Now, ooh, geez, just come along. All right, so let's take a look at the first one. So we have S is 2, 1, T is 8, negative 4, and R is negative 1, 3. Find the centroid. All right, so the centroid is going to be 2 plus 8 minus 1 divided by 3. And then we're going to have 1 minus 4 minus 3 divided by 3. This leaves us with 9 over 3 and negative 6 over 3, which in the end gives us a centroid of 3, comma, negative 2. 2, 3, 1, 2. So there is our centroid right there. Solve for the next one on your own. Bless you. All right. Who's still working on it? All right, let's see. Who is next? We have Landon. Wait. No, I think he switched. He switched classes. I just didn't update yet. Abigna. What is the centroid? What'd you get? 1, 2. Nice job. Anybody have any questions on that? All right, so now we're back to writing. Yay. So now we're moving on to altitudes. All right, so your I can statement for altitudes in a triangle is I can find the point of concurrency for the altitudes of a triangle. Your vocabulary would be concurrency of altitudes theorem and orthocenter. I don't know what that is. I'm not going to lie to you guys. AOMC, I don't know what that is. So, but that's okay. I don't have to have that answered necessarily. Okay, there's a slight error here. So if P is the point of concurrency of ABC, AZ, BY equals C, it should be CX, not CZ. So what they're saying here is if you are finding the point of concurrency using altitudes, the altitudes themselves should be equal to each other. Yes. What do you mean?
It's like that's like all the things in parts of the triangle, like the altitude.
Are you talking about like where the points land?
The angle by it's like people like that works together. I don't know why not this one.
I know where the points land are the same, kind of. I'm not gonna say it's perfect. Yeah. Yeah, those how you find them, yeah. Perpendicular bisector is circumcenter. Was that what it is? Oh. I didn't know that. I just learned. Thank you. Learn something new every day. All right, everybody still writing? All right, so again, this is an error. I don't know what I was thinking, but this should be orthocenter. So the orthocenter is the point of concurrency for the lines containing the altitudes of a triangle. So tomorrow when you guys complete your ed puzzle, it's going to go over the specifics of each point of concurrency. Circumcenter, incenter, orthocenter, centroid, okay? And then hopefully after that, it should be much clearer as to what goes with what, okay? On your homework for tonight, there are a few review problems on there as well. Not insane, but at least like just identifying, hey, what do you see here, right? Okay, so it says use a diagram to identify each segment. Why don't you guys give that another go? Try that one on your own. And I'll show you guys in a minute what each one is. All right, anybody still working on these? All right, big reveal. Here's what we got. So we have AC is the median, which makes sense. It doesn't say this is bisected, just says that's a right angle there. BA is actually an altitude. It just so happens that it's intersecting AD, which is perpendicular. It never said it had to be a bisector, it just said it had to be perpendicular. Okay? Your angle bisector is DG, which makes sense because of those tick marks right there. And the perpendicular bisector of is CE. Okay? Questions on that? All right, so again, here is the next part. So it says sketch the perpendicular bisectors on each side of the triangle. So in this case, if you look here, the inside, this is for an acute triangle. This is, if it lands on, it's going to be a right triangle. And if it lands outside, it's going to be obtuse. Now, this is very, very similar to the circumcenter, right? However, the only difference is in the right triangle, they land in two different spots. Here, it's landing directly at the right angle for an orthocenter. Where does it land for a circumcenter? Where did it land? Who remembers from yesterday? It didn't land inside, it landed on. So it's got to land either on the legs or on the hypotenuse. Where did it land? Who remembers? Yeah. It did land on the hypotenuse. Very good. Okay. Now, this one might be a little weird to look at, but I want you guys to think of it this way. Remember, if it's acute, it's landing inside. A right triangle, it's landing kind of at that. So it has nowhere else to go if you go obtuse. It has to go outside of the triangle if we moved it around. I didn't want like a ton of lines on here, so I didn't add them. But if you look right there and extend those lines, that would be perpendicular to that line. Okay. Does that make sense? Again, it's just to give you kind of an idea of what's happening. So now the question here is, what conjecture can you make about the location of the circumcenter for acute, right, and obtuse triangles? So essentially all locations are inside, on, or outside the triangle, except for a right triangle, the circumcenter lands on the hypotenuse. Show of hands who's still writing. Okay. All right. Caught up? Ladies, caught up? All right, so let's take a look at example 2. It says, can the same segment be more than one of the special segments in a triangle? So for example, can a segment be a median and an angle bisector at the same time? If so, draw it and explain why your diagram must be valid. All right, so in terms of this, it says yes for an equilateral triangle, just like we kind of talked about yesterday. The altitudes of an equilateral triangle will intersect the midpoint on the opposite side. That part is going to be very important coming up here after topic 7. We're going to see a lot of altitudes and medians kind of being the same line segment, okay? All right, who's still writing? Okay. All right, let's take a look at our examples. So example 3, it says if AD is a median of ABC, BD is 3x minus 14, DC is 2x plus 1, and the measure of ADB is equal to 7x plus 1. Find the value of x. Is AD also an altitude? Explain. All right, so in this case, they're saying, okay, AD is a median, definitely. So this and that end up being congruent. This is 3x minus 14. Sorry, it would help if I made that look like a 4, huh? There we go. And then the CD is 2x plus 1. Now they're telling us that the measure of ADB, so this guy, let's get a different color, right here. All right, that is 7x plus 1, and we need that to equal 90 degrees in order for it to be an altitude, right? So step 1 is to take 3x minus 14, set that equal to 2x plus 1. Someone tell me, what is x going to be here? Good. 15. And the easiest part of this is that we're just going to take that and we're going to find the measure of angle ADB, by substituting in that 15. So this will be 7 times 15 plus 1, which leaves us with what? 106. Is 106.90? Nope. So therefore, we know without a doubt that AD is not an altitude. Try example 4 on your own. You're going to solve for x and y, and then see if cy is an altitude. All right, show of hands. Who's still working on this one? All right, let's see. Devanshi, give me what x equals. Very good. And then we're looking for y. Let's see. Holly, what does y equal? 20. And then we're trying to find is C, Y, and altitude. Shane, you said no? Why?
Well, peer pressure, but
Peer pressure?
It just doesn't know.
You just kind of went with it?
Yeah.
Nick?
The measure of angle ABC, 58 degrees, 180 minus 58 is 122.
Okay.
Which would be BYC. That's not 90. That's not
You're super close. You missed one more angle. You only did 180 minus the 58, right? Where are you looking for linear pairs at? Yeah, but then you also need like a YCB. Do you see what I mean there? So who else? Who has something else? Yeah.
Okay, so I did 180 minus ABC minus ACY, and I got 90 degrees. So yeah, CY is an altitude.
Okay. So in this case, you had to solve for ACB. That was y plus 12, right? And they told you that the whole thing ACB was 4y minus 16. Well, that means that I have y plus 12 here also, and I could set that equal to that to get the y equals 20. That makes things a little easier, but then what happens here is since I have this whole thing, that is 4 times 20 minus 16, which gives us 64, but you only need half the angle. So you divide that by 2, giving you 32. So this angle ends up being 32. This angle is correct at 58. And then if you take 180 minus 58 minus 32, good Lord. There we go. All right, you're going to get 90 degrees. So it is, in fact, an altitude. Okay, does that make sense, Shane? Nick, does that make sense? All right. All right, let's move on to example 5. All right, so now we're going to talk about graphing the orthocenter. Now, I'm not going to lie to you guys. There's a problem that has like 2 sets of points on your homework tonight. You're going to need a piece of graph paper to do this. There's no way around it. Okay, so get a piece of graph paper, print one up, something. But last period's like, well, how do I do this without graph? You don't. You need a graph. You need to graph. Okay, sound good? Now, the main thing you need to remember about these, especially from Algebra 1, 8th grade math, kind of whenever you started learning this, is that remember to calculate slope. It's y2 minus y1 over x2 minus x1. Okay, so you're going to need that formula. Now, your goal here, okay, is to pick a point or a vertex and use the line opposite that to draw your altitude. Now, looking from point C to line AB, we're going to look at the slope of line AB. Okay? What is the slope of AB? Who can tell me? Another one from Algebra 1. You got 2. It's either 0 or undefined. It's undefined. Remember, you guys ever see who was it? Slope Dude? Undefined, right? All right. So it's undefined. We need the perpendicular slope of that undefined. What's it going to be? Jane? 0. So what I do is I connect here with that C and I draw a line. Wow, they're really singing hard next door. Through that is perpendicular with a 0 slope. Okay, so there is my first line segment. Questions on that so far? Okay, now we got to pick a minimum of one more. Now remember, you're going to have segments actually that go through each vertex, but we need a minimum of one more to find out where this lands, right? All right, so what I'm going to do is I'm going to pick from A to BC, okay? So A to BC, that means I have to find the slope of BC. Now I have 2 minus negative 2 minus 3 over 3 minus 8, which gives me negative 5 over negative 5, which leaves me with a 1. Am I done though? No, what do I need? Yeah, I need that perpendicular slope. So that perpendicular slope is actually going to be opposite reciprocal, which is negative 1 in this case. So looking at A, oops, providing it will let me, I'm going to go down 1 over 1 each time until I'm perpendicular with BC. So this is actually giving me the point of concurrency, which is right here. So my orthocenter is 4, 3. Does that make sense? So again, pick the vertex. This part right here saying I'm going from C to this line helps me just kind of keep things in order. If you understand that, then you don't have to worry about it. Okay? But I want you guys to try this on your own for example 6. Now, it's not going to be as nice because we don't have that undefined or zero slope. So you're going to have to calculate the slope twice. But pick one, or pick two, I mean, and go for it. Like I did B and A. But there's nothing saying you can't do C. Okay? All right, so go ahead. Yes. All right, show of hands. Who is still working on example 6? If you are, it's fine. I just want to make sure. Okay. All right, let's take a peek at this. So I'll show you kind of, I'm not going to go through how to calculate the slopes, but I'll show you kind of what I did. So I went from B to AC, which means my slope of AC was, I got the perpendicular slope of -5/2. How do we do so far? Okay. And then I did A to BC, and the perpendicular, I should put perpendicular here, I didn't think about that. Perpendicular slope of BC, in this case, I got 9/8. How do we do? So far, so good? Okay. Before I graph it, though, someone tell me, what is the orthocenter? Who got it? Shane? 2-4. Very good. All right. I'm going to graph it real quick. So I'm going from B to AC, and I'm going down 5/2. So 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. So there's that one. And then this one, it seems a bit odd, but you're going up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I actually land on that orthocenter. It's like right there. So there's that, and there's that. Okay. Questions? Okay, that's it. Those of you watching at home, have a great day.